Vibe coding was about exploring ideas quickly, often tolerating bugs because the cost of being wrong was low. Professional agentic engineering raises the quality bar. You are responsible for the software you ship, meaning vulnerabilities are unacceptable. Look at this trajectory model. At a slow speed, a half-degree error is easy to catch and correct, but increase the speed of development exponentially, and that same tiny half-degree divergence compounds rapidly. You end up miles away from your intended destination before you even realize a mistake was made. Here is the standard enterprise AI architecture mapped out. We have the reasoning engine, the tool layer, and the memory layer operating smoothly at the bottom. But look at the top tier, the governance layer. It is brittle, unstandardized, and struggling to hold the system together. Because this governance layer fails, MIT data shows up to 95% of enterprise AI pilot programs stall with no return on investment. The solution to this structural gap is a disciplined operating model. We call this architecture spine. Taking away human bottlenecks in the software development lifecycle gave us speed, but those bottlenecks enforced necessary boundaries. Without a structure to replace them, projects drift into collapse. Let's put this framework into practice. Suppose our team is managing a 2-week sprint to build a secure user authentication portal. On the left is a traditional project outline, a static document sitting idle on a server. On the right, we see the first pillar of spine, scope. Scope acts as a machine-readable boundary directly inside the workflow, actively repelling out-of-bounds feature requests before they ever reach an agent. When an autonomous agent encounters vague instructions, it will not pause to ask for clarification. It picks an interpretation, guesses confidently, and builds against it. The integration breaks weeks later, making ambiguity the single most expensive error in AI development. To solve this, we apply the second pillar, precision. Watch how this block of requirements behaves. The precision layer strips away multiple interpretations, forcing every acceptance criterion down to exactly one strict, unambiguous meaning. By establishing a rigid scope and forcing precise logic before the agent writes a single line of code, we prevent hidden, catastrophic integration failures down the line. As the project moves forward into new sprints, a new risk emerges, context rot. When long-running agents are fed too much historical token data, their accuracy drops and their logic becomes erratic. This diagram shows an AI model attempting to process information from several previous sprints. The agent becomes overwhelmed and gridlocked by overlapping decisions and unsorted background noise. The third pillar of our architecture is intelligence. Crucially, this layer is not the agent doing the active coding. It is a separate analytical system sitting above the agent, managing its strict attention budget. Notice the intelligence layer in action. It actively sweeps away irrelevant history, curating and delivering only the exact, neatly organized data packets required for the immediate task. In a multi-agent architecture, the system's ability to selectively forget data is far more vital than its capacity to remember everything. While the agent works, the navigation layer acts as the system's autopilot. It constantly compares the live code being generated against the original project brief. You can see this real-time measurement here. The system catches minor code drift and gently redirects the agent mid-flight, long before an error becomes permanent. With scope, precision, intelligence, and navigation handling the upstream logic, the final layer, execution, operates differently than standard AI assistants. The AI is no longer burdened with making product decisions or interpreting vague ideas. Freed from upstream thinking, the agent serves its true purpose. It becomes a pure, high-speed execution engine building exactly to the brief. Let's test this architecture. If an agent in Sprint 4 writes a piece of code that contradicts a database decision finalized back in Sprint 1, which two spine layers failed to do their job? The failure occurred in intelligence, which delivered conflicting context, and navigation, which failed to correct the drift. When models output bad code, the root cause is almost always a failure of structural governance, rather than a failure of the model itself. By following this discipline, our sprint delivers the secure authentication portal at high speed, completely aligned with the original security intent. For project leads, even those who have never written production code, the role has shifted. Your job is to engineer the structural backbone of the project, maintaining clear operational boundaries. This structural backbone operates through 5 distinct functions. Scope guards the project. Precision clarifies the intent. Intelligence reasons the context. Navigation corrects the path. And execution delivers the code. AI agents exist to execute human thinking. They do not replace the deliberate planning required to build software. Speed in software development is earned through discipline. When your architecture has a rigid spine, moving fast is mathematically safe.